Algebra 2, we're working on lesson 8 today. We're going to graph the sine and cosine function. It's going to be very similar to when we graphed our Ferris wheel. So let's get into it. You guys are going to see an exploratory challenge 1 that we are not going to do. It's something hands-on that we could have done in class together with yarn and spaghetti and glue sticks. But we're just going to get into exploratory challenge 2, which sort of gets into the math of things before playing with crafts, which could have been fun, but this will give you more time to finish your classwork, or sorry, your problem set. Alright, so first of all, complete the following table by using the special values learned in lesson 4. Give values as approximations to 1 decimal place. So I went ahead and calculated all of these out, just to give you an idea. Like, sine of theta when theta is 45 is square root of 2 over 2, which if you actually crunch the numbers, it's 0.7071. But they said approximate to 10, or to 1 decimal place, or to the tenths, so we stopped right there. So take a look at those and just see, or we're going to use this information on the next slide to actually graph it. The other thing that you can do is in your calculator actually type in sine of, for instance, 210, hit enter, and you would get negative 0.5. Next slide. So first of all, I, for part B, graphed in red. Okay, just the values in the table. And it was a lot easier to graph the values in the table at points like 90 degrees, which I put at positive 1. And I just made 1 here and negative 1 there. So for 90 degrees, 1, for 180 we had 0, and for 270, negative 1, 360, 0. So it was easy just to go here from the table in red. And that would be just the interval 0 to 360. Now part C asks you to extend your graph to negative 180 and positive 720. And it's just a great little pattern. Remember, it's a periodic function, so it just repeats. So I came back down and then up and back down. Okay? And like I said here, I finished that one in blue. Okay, you guys are going to have to copy this down. I wrote it in advance. My handwriting can tend to be a little bit better if I'm not trying to write and talk at the same time. So that's what I tried to do. If we look for the interval of negative 180 degrees to 720 degrees, which is the whole graph that we graphed blue and red, describe the values of theta at which the sine function has relative maxima and minima. So first of all, the relative maxima, which are the highest points, are at 90 and 450. The relative minima occur at negative 90, 270, and 630. I just squeezed a copy of that graph from a previous slide just to show you our maximums at 90 and 450, our minimums at negative 90, 270, and 630. For the whole interval for part E, describe the values of theta for which the sine function is increasing or decreasing. So we have little intervals where it increases, and if you look, it's from negative 90 to 90. We're going up. Okay, we're increasing in y values. And then from 270 to 450, and then from 630 to 720. That's where we stop because that is the interval that we're talking about. And then decreasing, negative 100, that should be 180, I'm sorry. That's a typo. It's not really a typo if it's handwritten, but a typo nonetheless. So negative, oh goodness, and then I did that. That is hilarious. Let's erase. Oh, I can't erase it. 180 So negative 180 to theta, or sorry, negative 180 to negative 90, it decreases. And then 90 to 270, it decreases. And then 450 to 630, it decreases. Part F, for the interval negative 180 to 720, list the values of theta at which the graph of the sine function crosses the horizontal axis. Okay, every place it crosses. Cool. G, describe the end behavior of the sine function. So the sine function will continue to oscillate, that's our periodic function, between negative 1 and positive 1 as theta goes to infinity, excuse me, or theta goes to negative infinity. And all that means, let me get a different color. If we have the graph, as we are going to infinity, we're oscillating between positive 1 and negative 1. And as we're going to negative infinity, we're oscillating between positive 1 and negative 1. Based on the graph, is sine an odd function, an even function, or neither? Okay, this is new information for us. Sine is an odd function because the graph is symmetric with respect to the origin. This is just a new thing that we're learning. It's called an odd function when it's symmetric with the origin. And finally, part I, repeats. Well, this one is a little easier. The sine function repeats the same pattern on every interval of length of 360. Okay, 360 is one full turn. After that, the values of the sine just repeat and repeat and repeat, which is that periodic function. So it starts at 0 and goes to 360, and that's how the sine function works, and it oscillates between 1 and negative 1. All right, let's summarize just a few things before we move on to the cosine function. First of all, we talked about on our graph at which values is theta at its maximum. Well, we wrote down 90, 450, and negative 270. We actually didn't write down 270, but that's okay. Are there any more? Are there any more values where theta is at its max? It's an infinite number of values. Because the sine function repeats, and it keeps on repeating. Are the values you listed the only places where it's at its maximum? We just said that. The graph is going to repeat, and you're going to get an infinite number of values. How could we write an answer to this in general terms without listing values? We could say that the sine function is its maximum. Sine function, well, let's not do that. Is at its maximum, and we can say it starts at 90 because the sine function, remember at 0, it was 0 and goes up and down. This first maximum was 90. So it starts at 90, and then 90 plus 360, and then 90 plus 720, etc. These are all multiples of 360. So we could say 90 plus 360 n, where n is an integer. Cool? Sine at its minimum, let's get that out of the way. And at the minimum, the first value was, we had negative 90, for our graph at least, 270, 360, 630. So we're just going to start at 0 and say our minimum is at theta equals 270 plus 360. And we could keep saying 360 over and over and over again, so we can just say 360n, where n is an integer. Cool? So there's our general equation for maxima and minima. Alright, let's move on to cosine. You can either use your calculator to calculate the values. We know from our work in previous lessons and the charts that we have that the cosine of 30 is square root of 3 over 2, which if you crunch those numbers in your calculator, you'll get this, which rounded to the nearest tenth is 0.9. So I went ahead and filled out the table. You can do so also, and then I graphed it. In blue, I graphed just the table, where we're starting cosine of 0 degrees is 1, then we oscillate down and back up again. Then if you just continue the pattern through the rest of the graph, which I did in red, my table was in blue, and then I extended the graph in red. Right there. Okay, let's answer the questions. They should be easier for the cosine because we went through the same steps for sine. So if we look at, for the maximum, we're at 1 at 0 degrees and 360 degrees. And if we keep going, 720. Minimum is at negative 180, 180, and 540. We increase between negative 180 and 0, 180 and 360, and then again 540 to 720. We decrease from 0 to 180, 360 to 540. We cross the horizontal axis at negative 90, 270, 450, and 630. To keep on answering our questions, our end behavior, we're going to oscillate between negative 1 and 1 as our degrees, as our theta goes to infinity and negative infinity, just like sine. Based on the graph, cosine is an odd function, an even function, or neither. How do you know? Well, this one is an even function because the graph is symmetric with respect to the vertical axis. If you remember, sine went like this, and cosine goes like that. Not bad. So it's considered an even function. The cosine function repeats the same pattern on intervals of length at 360 degrees because 360 degrees is one full turn. After that, the values of cosine continue to repeat, just like sine. New question compared from the sine questions. We didn't have this one. How are the sine function and the cosine function related to each other? The two functions are horizontal translations of each other. We could shift the graph of either function horizontally to line up with the graph of the other function. If we overlaid those two graphs on top of each other, they would look exactly the same, just shifted by 90 degrees. And that's it. What's new here that we didn't introduce in the lesson is the definition of period and amplitude. Let's see. Right here we have period. If a least positive number p exists that satisfies this equation, it's called the fundamental period, or if the context is clear, just the period of the function. The period of the function is from maximum to maximum. And the amplitude is from the horizontal axis to the maximum. It's half the distance between the maximal point and a minimum point on the graph of the function, and half the distance. The minimum would be all the way down, the maximum at the top, which we have between 1 and negative 1. So half the distance would obviously be from the horizontal axis. Cool, that's it for today.